know a lot about gases. Air is a gas. Actually, it's a mixture of several gases, and it surrounds you all the time. Air pumps the tires of automobiles, serves as springs in trucks and buses, and drives tools such as jackhammers and power wrenches. And it can even provide a soft cushioning in air mattresses when you go camping. Although you can feel air all around you, you can't actually see it because the gases in air are colorless. So that was an example of how gas can be pumped into a balloon. And now I'm going to be showing you an example of how gas will be released from a balloon. We're going to be explaining gas laws, and the first one I'm going to be talking about is called Boyle's Law. And Boyle's Law is written as PV is equal to K. So P is equal to pressure, V is equal to volume, and K is equal to Kelvin. And basically, Boyle's law states that at a constant temperature, the product of the pressure and volume of a given mass of an ideal gas in a closed system is always constant. Another gas law is called Charles' law. And Charles' law is written as V over T is equal to K, where V is volume and T is temperature, and K is equal to Kelvin. Charles' law states that for a given mass of an ideal gas at a constant pressure, the volume is directly proportional to its absolute temperature, assuming in a closed system. Another gas law is called Gay-Lussac's law, and Gay-Lussac's law is written as P over T is equal to K, where P is equal to pressure, T is equal to temperature, and K is equal to Kelvin. And this law states that for a given mass at a constant volume of an ideal gas, the pressure exerted on the sides of its container is directly proportional to its absolute temperature. Another gas law is called Avogadro's law, or simply put, Avocado's law, because it's easier to remember that way. And this law is written as V over N is equal to K, where V is equal to volume, K is equal to Kelvin, and N is equal to the amount of substance in moles. And this law states that the volume occupied by an ideal gas is directly proportional to the number of molecules of the gas present within the container. So the last law I'm going to be talking about is the ideal gas law. And this combines all of the previous laws and puts them into one simple equation. And this equation is equal to PV equals nRT, where P is equal to pressure, V is equal to volume, N is equal to the amount of substance in moles, and R is equal to the gas constant, which is equal to 0.00821, and T is equal to temperature. And the ideal gas law shows the relationship between pressure, volume, and temperature for a fixed mass quantity of gas.
If I have an unknown quantity of gas, a pressure of 5.6 atm, a volume of 31 liters, and a temperature of 87 degrees Celsius, how many moles do I have? Well, let me show you a little tool so you don't get confused. So, P equals pressure, which is this. ATMs is the clue to understand which one's pressure. V equals volume, and when it has to do with a measurement, like liters for instance, that's when you know that's volume. T equals temperature, and like Fahrenheit, Celsius, and Kelvin, which we have right here. But we can't use Celsius, and there's an equation to help you turn that from Celsius to Kelvin. We'll get to that soon, but let's get through this first. R is a constant that we use in each one of these equations. which is 0.00821. And it's like using pi in a math equation, but except we're using r in this one. So n equals moles, which is what we're basically solving for. So, how to set this up? It goes P E equals N R T. And N is the one we're solving for. So we divide this by RT on both sides, like you do in math with like Miss Blast or something. And then we set it up, we plug in the numbers. P is the pressure of 5.6, and we do the volume of 31. And then we get, and then we put the numbers underneath too. R equals 0.00821. And, oh shoot, almost forgot. Sorry. Here's how we get temperature. It's 273 plus 87 degrees. And we get that. You can use your calculator later on. I'm just getting this on my paper. 16. And then we solve that. We get, if it's easier, we'll multiply first. So n equals oh yeah, 29.556 over 37.2, which equals 0.79 moles, which equals that. And you can use your calculator if you don't believe me. But since I'm an honest guy at school, you obviously will believe me on this. Now I'm going to explain gas from a chemistry viewpoint. Gas is a state of matter in which substance does not have a specific shape or volume of its own, but adapts from the size and form of its container. A liquid, like a gas, has no shape of its own, but does not have a definite volume. Both states of matter are referred to as fluids because of their mobility or tendency to flow. A gas is actually a low-density fluid because the molecules are much farther apart than in a liquid, where molecules are in close contact with each other. For example, at room temperature and at atmospheric pressure, the density of air is about 0.0012 grams, which is 0.00042 ounces per cubic centimeter, whereas the density of liquid air is approximately 0.81 cubic centimeters. At its normal boiling point of negative 209 Celsius or negative 344 degrees Fahrenheit. This corresponds to an average separation between molecule and gas phase that is about 9 times larger than that for the liquid. A liquid is thus called a condensed phase or a high-density fluid, and is roughly 1,000 times more dense than a gas. A compound exists in the gaseous state because the attractive forces between the molecules are weak. The average distance between them is large. Liquefaction or condensation of the gas may occur in the kinetic energy of the molecules. It is reduced by cooling, or the in-molecule distance is made smaller by compression. So basically, that would be like basically shrinking silly putty to like, you can stretch it out, but in this instance, we're just making it smaller, like we're making it into one really, really tight ball. So this has been our video of educating you on gas and their equations of how to solve them and basically how they work. We hope you appreciate this little small clip that Verona will be doing